students, welcome to my channel Physics by MKR. In the previous video, I explained you about relative velocities with the help of vector subtraction. Today's video consists of rain umbrella problems, again using vector subtraction. Here, regarding directions, we have only two directions in rain umbrella problems. That is, one direction is horizontal and the other direction is vertical. The horizontal direction may be towards east or south or west or north, whatever may be the direction reference, it is considered horizontal because the person can only move in the horizontal direction and it can be towards east or west or south or north. It makes no difference. Only direction is horizontal, that is person's velocity direction. And rain direction is explained on the basis of with reference to vertically downward direction because rain is always falling down. So I consider the vertically downward direction as one reference and horizontal direction as another reference. Because there are only two velocities in these examples. One is person's velocity, another is rain velocity. And another thing is relative velocity of rain with respect to person. If VR represents actual velocity of rain, that is when the person is at rest, and VP represents the velocity of person in the horizontal direction. Now relative velocity, as you know, it is VR bar minus VP bar. And the directions, for example, you take rain velocity, rain is falling vertically down. Vertically down means I consider this direction as minus j cap, represented by the unit vector minus j cap. And person is moving in the horizontal direction means, for example, if the velocity of the person is 4 kmph, I represent the velocity of person as 4 I cap. So, actual velocity of rain is minus 3 j cap, and actual velocity of person is 4 I cap. Hence, relative velocity VR bar minus VP bar is minus 3j minus 4i. Here there are four quadrants direction wise. This is plus I plus j and plus j minus I minus j and plus I minus j. That means this relative velocity lies in the third quadrant. Third quadrant is nothing but the direction of extension from first quadrant. It is direction of extension from the first quadrant. That means the relative velocity of the rain appears to fall in this direction. That means it makes an angle beta with the vertical or alpha with the horizontal. And always the person has to hold in the relative direction of rain. That means this is the direction of umbrella in which he has to hold to protect himself. So always umbrella is held in the relative direction. Now there are only three velocities here. One is velocity of rain, and there is velocity of person, and there is relative velocity of rain with respect to person. So the problem is, if rain is falling vertically down with the velocity 3 kmph, and person is moving horizontally with the velocity 4 kmph, then relative velocity is nothing but minus 3j cap minus 4i cap, whose modulus is 5 kmph. This is about the magnitude of relative velocity. And the direction of relative velocity is given by an angle beta with the vertical in the direction of motion of the person, with the vertical against the direction of motion of the person. That means he has to hold the umbrella like this. So you have to measure beta. Here beta, this angle is beta, this angle is also beta. This is also beta. I am representing this here also. So, this is beta. Here, this is a right angle triangle. In this, VR is represented with the vertically downward direction, and the opposite direction of person is represented here. So, tan beta is opposite side by adjacent side. That is, tan beta is equal to VP by VR, which is 4 by 3. Tan beta is equal to 4 by 3. From this, beta is equal to 53 degrees with the vertical. So, relative direction of ray makes an angle 53 degrees with the vertical or 37 degrees with the horizontal. So, ultimately, the relative velocity of rain with respect to person is 5 kmph at an angle 53 degrees with the vertical in the direction against the direction of motion, or 37 degrees with the horizontal against the direction of motion. In this example, you are given relative velocity of rain and velocity of person. Now we have to find the actual velocity of rain. We are considering the real velocity of rain when observed by a person when he is at rest. And when the person is in motion, we consider it as the relative velocity. So in this problem, rain appears to fall with a velocity 4 kmph vertically down to a person running with a velocity 3 kmph towards west. The actual velocity of rain is, this is the question. So whether he moves towards west or east or north or south, we consider it as horizontal direction. I already told you. So that's why the velocity of the person is given by Vp bar is equal to 3I cap. And you are given relative velocity vertically down means it is represented as minus 4J cap. As you know, relative velocity is the difference of real velocity minus person velocity. So actually real velocity VR bar is V relative plus V person. That means by addition, vector addition, we are going to get real velocity of rain, that is minus 4J plus 3I. To find relative velocity, we use vector subtraction. To find real velocity, we use vector addition. So VR bar is V relative bar plus Vp bar, and its magnitude is given by 5 kmph. And regarding the real direction of rain, this is real direction of rain, this is the relative direction of rain. So when the person is in motion, he is holding the umbrella in this direction to protect himself. But when he is at rest, he has to hold the umbrella in this direction. That means making an angle beta with the vertical from his back like this. He has to hold the umbrella like this. Now tan beta is equal to Vp by, this is V relative. So here Vp by V relative 3 by 4, which is 37 degrees with the vertical from the back side of the person. Thank you for watching my videos.